are going to use the same setup that we've seen for experiment C. We are going to record, but first we are going to record the mass of 1 tablet of Alka-Seltzer. So in each one of these there is 1 tablet. Okay? We record the mass of the 1 tablet. Then we are going using the analytical balance. Then 1 person per bench is going to crush the tablet in the mortar, okay, using a pestle, so like this. When you obtain the powder, you're going to measure 0.200 grams of the Alka-Seltzer powder with an analytical balance. Remember to use all the sig fig approximately. And then you're going to prepare the setup as it is here. We have the flask, the beaker is going to be filled with water. You're going to have the Erlenmeyer flask of 125 milliliters. We are going to have the sensor as close as possible to our Erlenmeyer flask, hopefully not touching the walls of the beaker. And then we are going to set up the 2 sensors, the pressure sensor. There is this one right here on the channel 1, and the temperature sensor on the channel 2. And so here are your readings. We fill up this syringe, we unscrew it, this septum is closed. We fill it up to 5 milliliters with hydrochloric acid that is in the hood. Remember that the 5 milliliters is not, the mark for the 5 milliliters is for the upper part of the plunger, not for the lower part, because we want to use excess of hydrochloric acid to complete our reaction. Okay? So we place the 200 milligrams of the 0.2 grams, I think it is, or 200 milligrams of Alka-Seltzer in the flask, open the stopcock, push in the acid, push up to the mark of 5, and close the stopcock. Remember that we need to always push up because we don't want to increase the pressure erroneously. When we fill up the syringe, we want to make sure that we have no bubbles, that we have all the hydrochloric acid. So we are going to have a flask with 20 milliliters per team of hydrochloric acid. Please, let's not waste chemicals, okay? So then what we are going to do is we are recording. First we record the initial temperature before we push the plunger, okay? Then we open the blue valve, add the hydrochloric acid, retract the plunger, record the final pressure as Pmax, and the final temperature. The temperature should stay the same throughout the experiment. It's not. Then we repeat these steps 2 to 10, until we get at least 3 measurements of the pressure with a certain precision, plus minus 2.0 kilopascal. Okay? Once we have done that, we're going to do calculation that we are familiar with. So we are going to use this time the pressure that we calculate from the delta P of the sensor, and temperature from the delta T of the sensor. So this will give us the pressure of CO2. So P max minus P initial. And remember the change in pressure should be between 18 to 20 kilopascal. If it is less than that, your sensor is not working. You remember that we saw that some sensors were not working? So test it immediately. The temperature, we get it from the sensor attached to the lab quest as well. The volume, by filling the Erlenmeyer flask with water and measuring either with a gravity cylinder or with the balance. Either we use the gravity cylinder to measure the volume of water, which is going to be equal to the volume of CO2 developed in the reaction, or you can measure the mass in a balance if you want, and using density of water equal 1.0 grams per milliliter, figure out what is the volume. It's more, okay? Then we are going to use the calculated number of moles to apply the reaction to determine the mass of sodium bicarbonate in the 200 milligrams of our sample. We're going to go from, let's see here, let's do it here, from the moles of CO2 to the moles of sodium bicarbonate to the mass of sodium bicarbonate. Same thing that you did in the pre-lab. What do we do to go from moles of carbon dioxide to the moles of sodium bicarbonate? What do we use? We use the mole ratio in this reaction. Mole ratio between the sodium bicarbonate and the carbon dioxide. Okay? And then to get to the mass of sodium bicarbonate, we use the molar mass of sodium bicarbonate. Okay? Once we have done that, we report. Remember that out of the entire tablet, we use only 200 milligrams or 0.2 grams. So what we need to do is we need to convert this mass to the mass that will be for the entire tablet and calculate the average mass of sodium bicarbonate in each tablet, okay? And we calculate the percentage of sodium carbonate per tablet. And we report what is the percent error for the calculation compared to the mass of sodium bicarbonate that is recorded in the box of the Alka-Seltzer medication. And then you will know if they're saying the truth, if they're saying not the truth. Okay? Did they put really the amount of Alka-Seltzer that they say they have, or did they put less, or maybe there is more? Okay? And then you do the calculation for accuracy or precision of your measurement, because you have the true value in theory of the Alka-Seltzer in the tablet. Any question?
This is experiment 11, and what you need to do is record the amount of the active ingredient in each tablet of the Alka-Seltzer. To measure the mass of one tablet. So first we're going to place the paper, carrot, now we're going to place one tablet . Now record the mass of the tablet to the correct number of significant figures. After recording, we're going to crush the tablet with using a mortar and pestle. After we've grounded up the Alka-Seltzer using the pestle, we're going to need approximately 0.2 grams for each trial. So for the first trial, we're going to measure it out. So first place paper, carrot, and using a scapula, we're going to now measure the mass of the first trial to the correct number of significant figures. This is the Alka-Seltzer we're going to use for trial 2, so record the mass in the appropriate number of significant figures. This is the Alka-Seltzer we're going to be using for trial 3, so record the mass in the appropriate number of significant figures. This is trial 1 of experiment 11, so we have the Alka-Seltzer inside the Erlenmeyer flask. So what we're going to do is we're going to attach a syringe filled with approximately 5 milliliters of hydrochloric acid, of 1 molar hydrochloric acid. So we're going to attach it. Okay. Now record the initial pressure and temperature to the appropriate number of significant figures. Okay. Now we're going to add. Now record the maximum pressure and temperature to the appropriate number of significant figures. This is trial 2 of experiment 11, so we have the Alka-Seltzer inside the Erlenmeyer flask. We're going to attach this syringe that has approximately 5 milliliters of 1 molar hydrochloric acid. Here. Now record the initial pressure and temperature. Okay, now add it. Now record the maximum pressure and temperature. This is trial 3 of experiment 11, so we have the Alka-Seltzer inside the Erlenmeyer flask. We're going to attach the syringe filled with 5 milliliters of 1.0 molar of hydrochloric acid. Record the initial temperature and pressure of the apparatus. Now we're going to add the hydrochloric acid. Now record the maximum pressure and temperature of the apparatus. So after this experiment, we're going to measure the volume of the Erlenmeyer flask. So first we filled it to the top with water. We're going to put a stopper there, showing that that's how much volume it occupies, the water. Okay, now we're just going to put some in some graduated cylinders. This is cylinder 1, so read to the appropriate number of significant figures the final reading. Okay. This is graduated cylinder number 2, so read to the appropriate number of significant figures the final reading, and add this measurement to the first one to get the final volume of the Erlenmeyer flask.